Hello everyone, how's everyone doing? Alrighty, today we're continuing with Git, pretty much where we left off. So yeah, let's get straight to it. We're gonna do a quick recap, roughly what we learned last time, because it's been a few days, I'd say. So it won't hurt. Alright, let me just rename that tab. There we go. Alrighty, so we learned a little bit about the basics of Git. So last time we finished the Git basics recording changes to the repository. We learned some basic, about untracked, modified, and staged files, and how we can get Git status. It'll show us everything in the proper, let's call them buckets. We were able to add new files to be tracked via git add, as well as add modified files to the staging area using git add. Okay, git status, then was the shorter version, right? Oh, git commit, of course. We can do git commit or git commit -m to just do one-liner. Then we'll get status S to have this shorter view with what is it, staging and then a working directory. And then what else? We had the git ignore file, how it roughly works. Okay, with the negation being pretty powerful, like, hey, do not untrack this file. And what after that? We had tips, we get git diff, yep, that's pretty powerful. So that's awesome. Git diff stage to just see if you want to see what you've staged that will go into your next comment, it's git diff stage. Otherwise, we're gonna have a difference between our environment and staging, I believe. So, all right. We got more git diff cache to see what you staged so far. Oh, it's the same as cache stage, the same thing. Okay. Anything new here? The M flag for committing. All this fun stuff. Git add -a includes all changes. All right. And then we have removing files. So that's something we haven't tested properly. I think these were like two commands that we didn't get to. To remove file from Git, you have to remove it from your tracked files, more accurately, remove it from your staging area. So I think that's the one thing we need to actually test out, because it doesn't seem to be that straightforward. So to remove a file from Git, what does it mean to remove it from Git? You have to remove it from your tracked files, or more accurately, remove it from your staging area, and then commit. The git rm command does that and also removes the file from your working directory, so you don't see it as an untracked file the next time around. So let's imagine what do we have in this directory right now? Let's actually move here. ls. And we have our node modules, package.json, log.json, package.json, and readme. So let's imagine that we add some other random file. We can, I guess, go here and just do add something like not needed .md. Okay, and we'll just say this file is totally not needed. Okay, we'll write it. Oh, okay. I see. I haven't opened the file. Whoops. Come on. Q. And for now, and wow, okay. Not needed. Let's open that one. This file is totally not needed. Okay. Now we're gonna save it. So in our Git, we have the new file now, right? Not needed. There we go. So if we're gonna do git status, we have this not needed with 2 question marks. That means it's totally new and not tracked yet anywhere, pretty much. So we can do what? Add, right? Git add not needed.md. Okay, so status again. And we have it that in staging, it is added. So we added it to tracked. So what I understand is that, notice how you don't have to run git add on the contributing MD. Wait, here. So when we run the git rm, it should remove it from the staging area as it's not tracked. And also removes the file from a working directory so you don't see it as an untracked file the next time around. If you simply remove the file from a working directory, it shows up under changes not staged for commit. That is unstaged area of your commit status. So let's try a few things. Right now, I added this to staging, right? I mean, we still have our working copy. So what I'm going to do for now is I'm just gonna copy the not needed to not needed to. Okay, we're gonna have a working copy in our git status. We still have that the version 1 is in our staging area. So what happens if we're going to do git remove not needed, okay? Error, the following file has changes staged in the index, not needed MD. Use cache to keep the file or F to force removal. Oh. So here you're saying if you simply remove file from a working directory, it shows up under changes not staged commit. That is unstaged area in git status. So remove projects MD. Git status on branch master, your branch is up to date with origin, right? Changes not staged for commit and is deleted. Okay, so they're talking about something different. So that's something where we already have a file in our committed to our repository. If we're gonna do git remove, it's gonna try to totally delete it, unmark it, and whatnot. I see. So we'll get there in a second. But I recall that we read about this cached to keep the file or F to force removal. So the next time you commit, the file will be gone and no longer tracked. If you modified the file or had already added it to staging area, must force the removal with the F option. Okay, this is a safety feature to prevent accidental removal of data that hasn't yet been recorded in a snapshot and can be recovered from Git. Okay, so that's what it is. We have it in staging, which is not like a permanent way to store it. It's just temporarily there, right? And therefore, the Git is like, okay, we're not gonna let you remove it. So let's try the remove with the cache to keep the file. What will that do? Remove -- cached, and then we do not need it. Okay. Git status. Oh, so it just untracked it. We still have the file on our disk in our working directory. It's just not in staging anymore. Okay, so that's how we can kind of undo stuff that was pushed to put into staging. Oh, I didn't want it in staging yet. I can remove it just from there. It just goes back into whatever I have here. So what would happen if I would do git add not tested MD? Okay. We have it in staging, right? So what happens if I'm going to modify that file in the meantime, right? We're gonna add walla, okay? I'm gonna write it, and we get back to our Git status, we can see that we have it added as staging and modified and working directory. So what happens if I will try to remove it now? Remove cache not needed. Error, the following file has staged content different from both files. Okay, so it'll basically be like, sorry, nope, there's a conflict. Okay, so it checks for that. So what happens if we're gonna do -F to just force it? It removed it, and what's our Git status? Okay, just straight up removes both copies, and that's it. All right. I see. That's why we had the extra copy. All right, so let me copy the not needed 2 as not needed 1. Alrighty, and we're gonna operate on the not needed 1 still. Okay, so let's just do git add not needed 1. Ooh, not all. Add. Oops. There we go. So git status s. It's all good, and then we're gonna commit it. All right, we're gonna push in the repository. So not push it. That's wrong. We're gonna commit it. Git commit message adding a file that is not needed. Okay, bam. And now our git status s is just nothing crazy. But that means we still have the file. So if I'm going to do git remove not needed 1, it says it removed it, and we have it in our status that it's just staged. So we didn't really remove it from the Git yet. We just staged the action of removal. Okay. So that means that locally, we don't have that file anymore. We kind of deleted it locally and pushed it to staging. So I think that's exactly the same. Can we do git remove cached? So I can't undo it. Because notice that we have this here. I guess I remove. All right, git remove cached not needed 1.md. Oh, there are no files like that. How do I undo that change? I don't want to stage that change. What the heck? Git status s. It's here. They're not mentioning how to undo that. You can pass directories to delete a bunch of stuff. Absolutely. But how do I undo it? I guess we're gonna ask our trusty AI. Okay. Now Claude can reference past chats. Great, go away. When I use git rm to remove a file that has been already committed, it shows up as a deletion in staging area. My working directory also doesn't have the file anymore. How can I undo the, what do we even call it? Removal of the file so that it's not staged for deletion anymore and gets back on in my working directory. Something tells me it'll be like reset specific file or something. To undo a git remove operation, you have a couple of options depending on exactly what you want to achieve. So you can restore the file and unstage the deletion. So git restore -- staged and file name. Okay. And then git restore file name. I guess any of those? Or as a single command, git restore staged work tree file name. What? Alternative is git reset as in older approach. Oh, so there was git reset head. So we don't know anything about heads yet and checkout or whatever. What each command does: git restore staged removes the deletion from the staging area as in unstages it. Then we have git restore restores the file to your working directory from the last commit. From the last commit. Git restore stage work tree. This does both operations in one command. So let's try git restore staged file name, because we still have it as marked for deletion, right? So git restore staged not needed one. Bam. Git status S. Oh, look at that. So it went from being marked as deleted in staging area, now it's marked as deleted in our working directory. Okay, so that's why I need to do the git restore not needed one. And that restores it back to our working directory, right? Okay, that makes sense. So it's interesting how the restore just moves the deletion from one area to another. That's very interesting. But it makes sense. All right. I think we learned something. At least I did. Okay, great. So I think we have a rough grasp on git remove. Okay, that's good. And then was the git move. And that was another confusing one. And that was pretty much it. So what is the remove? Unlike many other VCSs, Git doesn't explicitly track the movement. If you rename a file in Git, no metadata is stored in Git that tells it you renamed file. However, Git is pretty smart about it. To figure out after the fact, we'll deal with detecting the file movement a bit later. Thus, it's a bit confusing that Git has a move command. If you want to rename a file in Git, you can run something like git move file from file to, and it works fine. In fact, if you run something like this and look at the status, you'll see that Git considers a renamed file. And yeah, it's renamed. Okay. However, this is equivalent to running something like this: move readme md to readme, then remove readme md and add remove. Oh, I see. So basically it will be first we kind of move file in our local copy, remove it from the actual whatever, make it into a staging that we deleted the MD file, and start tracking the README. And then basically Git will be like, oh, from those actions, looks like we have this new file has the same content, so they probably moved it or something like that. So Git figures out that it's a rename implicitly. So it doesn't matter if you rename file that way or with the move command. The only real difference is that git move is one command instead of three. So it's a convenience function. Okay, so I want to try it. So currently our git status is that we have that untracked not needed to. So let's remove the not needed to. Okay, so that we have nice and clean stuff, right? So we still have the not needed one. It's not in staging, not just in working directory, it's actually committed. So it's in the repo, whatever, in the history. So let's try to move it the manual way first. So we're gonna move, let's say, not needed one to be not needed.md or just txt to be even starker difference. Bam. what our Git status looks like. It looks like we have work directory deletion of not needed one and just new untracked file not needed. So we can do git add the not needed .txt, right? And now we added it, so it's marked as added, but we still have unstaged deletion of it. So if we were just to commit this thing, our Git repository at that point would be saying like, okay, I have not needed one.md and not needed present at the same time. But if I'm going to also what happens if I'm just gonna get, because they're saying that if I moved it, right, I have this as the deletion here. I need to say git remove this one to push that deletion from working directory to our, what do you call it, to our staging. But can I just do git add not needed one? What is it? What is that gonna do? Add the deletion? Yeah, that's what I did. So I guess if you have already a file removed locally, you can do either add or remove to kind of stage that. It'll be still a deletion, and in this case, it turned it to R because it's figured out, you know what, you just move this into there, and we can do git commit, and let's do cleanup. Bam. Done. Okay, that was simple. And the other thing is that if we wanted to move it again, it will be git move, for example, instead of all those three commands, because we will need to move it locally, right? Because if I'll do ls, we have just not needed. Let's see, we just call it to junk.md. Git move not needed to junk.md. Bam. And in our git status, yes, in our git status, we have instantly, okay, we moved this here and there, and it's nice and clean. So now, let's say I have this situation, right? I move this to there, and I'm like, I want to undo this. I don't want to push that change. You know, right now it's in staging area. Maybe I have a bunch of other stuff in staging area, and I just really don't care about this being there. Can I do something like, because the new one is junk md, can I do git remove cached junk? That worked. And what are we ended up with? We ended up with still having the deletion of not needed, and now the new untracked file junk. Okay, I see. So that means we would need to just remove our local file junk. And there you go. We actually removed our working file, and we still have the staged deletion of not needed. So I guess I was able to do remove cached not needed. Not needed .txt. I don't think so, right? It doesn't exist, so I needed to git restore cache or whatever, staged. I'd prefer staged. Not needed txt. And now it should be in our working directory, right? Status. Yes, it's in our working directory, marked as deletion. So I can do again git restore not needed, bam. And yeah, okay. I think I'm starting to get a hang of it. But wow, this is a lot of typing. That is a lot of typing. But all right. We got this through. It took me how long? 25 minutes, but I think it was worth it because I remember last time I was already tired and I just didn't want to test it. So now being fresh and rested, we got a good test, and I think we learned a little bit more than we were given. Okay, so now let's do Git Basics viewing the commit history. Alrighty. After you have created several commits, or if you have cloned a repository with an existing commit history, you'll probably want to look back to see what has happened. The most basic and powerful tool to do this is the git log command. These examples use a very simple project called simple git to get the project run, bam. Then you run git log in this project and you should see the output. So we're gonna do that in a second. So let's just look at git log for this repo. So cleanup, that's our most recent one, right? It doesn't show anything that we did with files. That, okay, we have cleanup, who did that, when, and the hash. Adding file that's not needed, great. Define project and add attribute, and there was our initial version here. Okay, only 4 commits, huh? I felt like we did 6 of them or something. Go figure. So let's just go back here and do, wow, I'm just gonna copy paste this thing. And we're gonna clone it, and this would be to whatever, simple git. All right. Simple git. It looks like we have lib, rake file, and readme. Rake file, isn't that like Ruby or something? The icon looks like Ruby. Okay, so git log. Oh, we have just 2? No, 3. Okay. So, okay, that's fun. So we see that the most recent was from 2008. Wow. Okay, here's the author of the book. Change the version number. Here we had removed unnecessary test code. Here we have first commit. All right. It feels so different interacting with it through the interface like that. Because normally you either go on GitHub and you can see the history. It's like, okay, it's on a website. It doesn't feel, it just feels normal. And a URL says, yeah, what's up? I'm doing good. How are you? What's up? Well, here it kind of feels different. You know, you see an old date. It kind of feels like, oh, these are some changes I'm covering from a long time ago. It just feels different. I don't know. Maybe I'm just still not that used to terminal and being, you know, on Linux and all that stuff. That's what makes it like feels more significant. So when you run git log in this project, you should get output that looks something like this. Yep. By default, with no arguments, git log lists the commits made in that repository in reverse chronological order. That is, the most recent commits show up first. As you can see, this command lists each commit with its SHA-1 checksum, and the author's name and email, the date written, and the commit message. All right, a huge number and variety of options to the git log command are available to show you exactly what you're looking for. Here we'll show you some of the most popular. One of the most helpful options is -p, or patch, which shows the difference, the patch output introduced in each commit. You can also limit the number of log entries displayed, such as using -2 to show only the last 2 entries. Okay, because if you have 1,000 commits and you just run git log, it will just try to calculate it for every single one, I guess. I wonder if there's like a default limit or something. That would be interesting. So yeah, git log -p to get the patch, as in, I know, just a bunch of diffs, and last 2. So what we're getting, this is nice out because we have actual color. There we go. Commit this. So that's the newest one, right? From whatever, that time. Change the version number. And we can see that the rake file, there was a change from 010 to 011. All right. And that's pretty much it. And then we have another commit which was remove unnecessary test code, which removed this if statement. And that's it. These are the changes. If I'm gonna do 3, we should see the initial one, because we have 3. So we have the one that we saw, the version, the unnecessary test code. And that's it. Oh, this is like less, so we can kind of go up and down. So we had our new line at the end of file. Whatever, and then we have the first commit, which shows that, okay, we added this file and that file and that file, and that's it. All right, so it shows it unless if we have, I guess, if there's above certain number of lines, it just switches to less. All right. This option displays the same information but with a diff directly following each entry. This is very helpful for code review or to quickly browse what happened during a series of commits that a collaborator has added. You can also use a series of summarizing options with git log. For example, if you want to see some abbreviated stats for each commit, you can use the stat option. Ooh, git log stat. Ah, okay, this looks familiar. That's for when you pull or push, right? You have basically, okay, for this commit, break file had some addition and some removal, right? One insertion, one deletion. This one had a bunch of deletions. This one had tons of additions. Okay, great. I really like that view because it kind of gives you an overview what's changing without, it actually shows you files without long content and just overview. Okay, something was added, something removed, and that already can give you an idea of, the fact that you have a message from commit and roughly which files changed. You already have an idea of what happened. You don't need to go start digging to start understanding what exactly, because this should be already enough to give you an idea. Okay, as you can see, the stat option prints below each commit entry a list of modified files, how many files were changed, and how many lines in those files were added and removed. It also puts a summary of the information at the end. Okay, I guess that's that line. Another really useful option is pretty. This option changes the log output to formats other than default. A few pre-built option values are available for you to use. The one-line value for this option prints each commit on a single line, which is useful if you're looking at a lot of commits. In addition, the short, full, and fuller, I like full and fuller, values show the output in roughly the same format, but with less or more information. Okay, I want to see them. So we're actually so both. So let's do git log pretty, and we need to equals, let's do short. Okay, so for the short one, we have, again, lots of empty space. Which commit, author, what, just the name. Okay, so that's it. Not a lot of info here. What if we're gonna do, what was it, full? Author and commit. What's the difference between author and commit? I mean, that's the only extra line we got. Other than that, we just have the name. So stats is actually more information than that. And then we've got fuller, which, what the heck? So, oh, wait a moment. So we have author and author date, and then we have separate commit and commit date. I wonder if this has something to do with like merging larger set of changes. I'm going to copy it into AI and see what it can tell us about it, because I am mighty curious. What's the difference between the author and commit. And why do they show up as different times? And now I have a typo, doesn't matter. We're gonna paste this here and see what we can learn. So the author and committer represent different roles in Git's workflow, and they can have different timestamps for several reasons. Author versus committer. Author, the person who originally wrote the code changes. Ooh. Committer, the person who last applied the changes to the repository. Ooh, when they differ. Same person, different times. You know, that example. Author date, when the changes were originally written, and commit date, when the commit was actually created as an applied. So confusing. So, number one, interactive rebase. Commits get new commit dates. Okay, so during rebase, dates can change. Cherry picking is again advanced. Amending commits. Oh, and I guess the author would become the one that amended it, but the wait, author would stay the same, but the commit would be different. Very interesting. And then applying patches with time delay. Git am some patch. Whatever that means. Okay, so we definitely don't know enough about Git to understand that. And then you have different people. So maintainer applying someone else's patch. Git apply patch from contributor.patch. Oh, I guess you can export those as like random patches. And git commit and author, set yourself as an author. Or whatever. Huh. It's interesting how much freedom there is to just set whoever is whatnot. There's no like strong authority. Okay, so I'm gonna ignore all this. We know that there were some shenanigans with rebasing, repository organization, or batch operations when the person, when the author of the book basically was prepping that repository for this very example, I guess. Although this is just like a minute and 20-second difference. Oh no, this is like entire 2 days difference. What about our repository? The one that we were, whatever, test one. If we're gonna run this, do we have something different? No, we have exactly the same times for everything. The moment we created commit, that's when it was recorded. Very interesting. All right, this is gonna be interesting to learn the stuff behind the scenes, how that works, because I don't recall Git, or let's say GitHub, showing this kind of information. And lastly, we have the one line. So we can do pretty one line. Okay, so we have the hash. Cleanup, adding a file. Define this is just the name. Okay, so just a big list. Alrighty, makes sense. Alrighty. So we have the one line that shows this. The most interesting option value is format, which allows you to specify your own log output format. This is especially useful when you're generating output from machine parsing. Because you specify the format explicitly, you know it won't change with updates to Git. All right, so here he specified pretty format, and it will be our whatever that is. So, oh, this is, I guess, the head, whatever, in some short format, dash author name, comma, author R. Date or when it was authored, probably, but R would be not absolute. It will be basically, what's the word for that? Just like file paths. So you have absolute paths and not reference relative. So probably that's time relative, time of authoring. That's why it says years ago instead of specific date. And then S, which is, I guess, the message. Okay, very interesting. Useful specifiers for Git log pretty format lists some of the more useful ones. Okay, so we have it described here. Capital H, commit hash, lower h is abbreviated, tree hash, abbreviated tree hash. So we have tree hash and commit hash. Interesting. Then we have parent hash. How many hashes are there? Author name, author email, author date for D, or author date relative. There we go. The relative one. A commenter name. So we already have all that differentiation here. And as a subject. Okay. There we go. You may be wondering what the difference is between author and committer. The author is the person who originally wrote the work, whereas the committer is the person who last applied the work. So if you send a patch to a project and one of the core members applies the patch, both of you get credit. You as the author and the core member as the committer. We'll cover this distinction a bit more in distributed Git. Okay, that makes sense. So this kind of aligns with what AI was trying to tell us. All right. The one line and format option values are particularly useful with another log option called graph. This option adds a nice little ASCII graph showing your branch and merge history. Okay, so if I'm gonna do git log pretty, I don't want the format. Let's just do pretty one line. There we go. Graph. Well, our graph isn't very interesting because we don't have any branches. We just have very simple, straightforward history. So does he have in his simple Git? Nope, he has the same thing, right? But he shows that, different repository, right? So I guess from the bottom is like the path, right? Merge git branch defunct into local. Then we have required time XML schema. And then here we have something still on the main branch, I presume. I never know which one, if it goes left or right, which one is the branched off one. But one branch will have those 3 commits, the other branch will be here, while they branched off somewhere in the past, and then here's the merge. Okay, great. Again, we haven't learned those things yet. And Anki says, what are you doing? I'm just learning Git. Reading the book about Git aloud and talking about it. So, yeah, that's your answer. As simple as that. All right, so this type of output will become more interesting as we go through branching and merging in the next chapter. Those are only some simple output formatting options to git log. There are many more common options to git log, options to git log. Lists the options. Oh, common option. Oh, as in that page. Okay. Oh gosh, this is sometimes so hard to understand. Common options to git log, which is a website, lists the options we've covered so far, as well as some other options, formatting options. That might be useful along with how they change the output. So we have some common options, which is P for the show the patches, right? Like diffs, right? Stat, which is awesome. Short stat, display only the changed insertions deletions line from the stat command. Ooh, so because if we're gonna do git log stat, right? We got this nice thing, but not nice thing about it is like, okay, we have entire head, we have all the author and date, and what if I just want like last commits? I don't care about who did what yet. So what is it? Short stat? Short stat. How is that shorter? Oh, we just don't get those. We don't have file listed. It's just, okay, that meant the password edited or something. Okay, so it's useless. All right. Name only shows the list of files modified after commit information. Can you combine them or something? Name only? Okay, so we got commits. Can we do stat? Combine them? Not sure. Abbreviated commit, show only the first few characters. So I guess that's what we can do. We do stat, but we don't want those super long ones here, so we can modify it by doing what happened? Stat. ABBREV commit. Wow, that's something that you definitely want to have as an alias. But yeah, commits are shorter, so it kind of becomes easier to read. Or maybe not. Relative dates instead, graph to display the ASCII graph. What does it look like when we have, let's say, stat with graph? Is that still compatible? Yeah, it is. It just shows longer lines and that's it. So that's useful. Anke says it's like making a Git website or what? No, I'm just literally reading the book about learning the Git, not the website GitHub, just the tool Git for, source version control. And I'm not making anything. And Grit says hello. Hello to you too. How are you doing? Okay, so this is somewhat easy. Oh, so we can do one line is just shorthand for that. Okay. All right, I like that. We can use it as a separate thing. Perfect. So we could do basically log, one line, and then graph, right? There we go. Perfect. All right, so limiting log output. In addition to output formatting options, Gitlog takes a number of useful limiting options. That is, options that let you show only a subset of commits. You've seen one such option already, the -2 option, which displays only the last two commits. In fact, you can do dash whatever the n number is as an integer to show the last n commits. In reality, you're unlikely to use that often because Git by default pipes all output through a pager, so you see only one page log output at a time. However, the time limiting options such as since and until are very useful. Since and until, oh, that's cool. For example, this command gets a list of commits made in the last 2 weeks. Git log since 2.weeks. Oh, this is nice and like easy to understand, right? And Grit says git log one line. Yep. And Anki says, yeah, well, I think it's too hard. Yeah, I mean, I used Git for years, but usually through different like interfaces. I don't know, Gitcracker, and at some point I've even used what is it, GitHub desktop or something, long time ago on Windows. And I just want to get like a deep understanding of how the command line works, but I don't want to stop there. I want to actually understand how things are working behind the scenes. So what really is the staging, how are commits, let's say, stored in a database, how that works. I want to understand that because it's a tool I'm using so much every day. And some of the more advanced concepts are just, scary to think about because when you need them, you don't want to screw up. You don't want to your weird shenanigans going on somewhere into the whatever public repo. So it's kind of like I'm reluctant to learn those things. And if I'll learn what actually happens behind the scenes, I'll be like, okay, I know what's going on. I know what all those scary terms mean, and I'll feel more comfortable and probably faster in using the tool because my brain won't need to even think about what's going on because I'll know exactly what's going on. It will be intuitive. So that's the goal. So I want to see that log in something that's a little bit more complicated. So let's go here. Let's go to surreal.nym. This should be a little bit longer, right? Git log, one line, and oops. Not this, wrong shortcuts. Okay, so we have some longer history here, right? It's from a long time ago, from initial commit, we can see that we had a branch out here that was merged in here. We go up, 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 and we do all this stuff. Okay, that looks fun. What will happen if I, instead of doing one line, I would do stats or stat? Because that would be probably a lot. Like last changes, that's from 25, right? Someone handle message decoding errors. We see a little bit of changes here and here. And if we're gonna keep going, we'll be having a lot of pages. Wow. Until we go to the initial one. Yeah. Okay. That is a longer output. Wow, that was a big commit. Holy moly. Yep. All right. So that's awesome. If I would do not stat, just normal output, will be probably even worse, right? Yeah, we have everything. But you can still see the graph on the left side, which is nice. You can just kind of have an idea. It even colors them different color. All right, all right. So, so using the color, you can probably kind of figure out which branch you're on. But let me zoom that in because too much. Okay, so it is the same color because this one I think is greenish. I know on this color scheme looks like this is greenish, this is bluish. Do they change color? Maybe I can change like a theme to something else. Oh, they do change color. We have this and that. Look at that. So can you track when they split? Okay, you can. So we had a blue one here, right? Blue, blue, blue. Blue continues here, so that's probably our main branch, while this one is different color. Okay. So kind of can see that. All right. Let's do what was I doing? What was I using? There we go. Anka says, keep going, you're amazing. Thank you. Oh yeah, I'll keep going. I still have some time. It's 10:53, so probably have an hour and a half, maybe 2 hours. I'll see how much I'm lasting. I just know that at some point I'll be slowing down because I'll be getting tired. But yeah, okay. So this is fun. This is awesome. And why did it stop working? Oh no. Did I break it? Did my keyboard stop working or something? No, my keyboard works. This works. I can input. Okay, so that's good. I think this page just... Yep, this one's totally frozen. Interesting. Why would that break? Can I do like tab close? I can. Sure. Tab new, and let's call it, rename again, Git. Okay. Can I move a tab? Well, I can move like that. I can't move any other way. Whatever, doesn't matter. So we were in surreal.nim, right? Wait, go back. Okay. And we were looking at the since and until. Okay, so I will be able to do, let's say, git log since, and let's say 2 months. I don't know if I touched the repo in 2 months. I haven't. Look at that. I can check. 4 months? No. 6 months? Okay, we've got some stuff in 6 months. Many commits. All right. Okay. Not bad. So that we since, or we could do until if we're going from the beginning to some. Can we do since and until at the same time? So git log since to this command works with lots of formats. You can specify a specific date like BAM or relative date such as 2 years, 1 day, 3 minutes ago. Okay. You can also filter the list to commits that match some search criteria, like the author option allows you to filter on a specific author, and the grep option lets you search for keywords in the commit messages. Wow, okay, so there's a lot of like inspection and search, and that makes sense because, you know, besides just allowing people to work together on a project, Git is supposed to give you the history, like search information. Okay, I want to see what this person did because I know that they did something important. Like I don't know, they told me that, oh, at some point I had this version of the file, or I did this interesting thing, so you can actually search it, or maybe you search for some topic inside there, right? Exploring GitHub repository and seeing how things were changing, it's often as effective as just learning the repository. It's one thing is to look at the project and its current state, like, okay, that's what it's doing. It gives you different kind of context when you look at the project and see how it changed over time. What happened with it? Like, oh, okay, we're going in that direction suddenly. Suddenly you have way more context. Okay, so you can specify more than one instance of both the author and grep search criteria, which will limit the commit output to commits that match any of the author patterns, any of the grep patterns. However, adding all match option further limits the output to just those commits that match all grep patterns. Okay, so again, we can do some fancy stuff here. Another really helpful filter is the S option, colloquially referred as Git's pickaxe. All right, pickaxe option, which takes a string and shows only those commits that change the number of occurrences of that string. That changed the number of occurrences. What? For instance, if you want to find the last commit that added or removed a reference to a specific function, you could call getlog as function name. The last, oh, okay. Let me see what we have in this repository. ls src, we have this. Of course. And let's look at utils. Oh, utils.nym. So let's just new vim, sure, here, and I can go to source real private into utils, right? So let's see, get next ID, get parse as in, escape integer. Let's just do $value. Let's see what the result will be if we're just gonna do $value. So git log capital S and function name will be, let's wrap in a single. I believe I need to do if I want $value. And what's going to happen? We've got some output. Commit here. Fix unsave enumcast, or make ranges use null instead of this. So these will be a bunch of things that have the value referenced. Okay, what if I would say that not just S value, what if I want to actually, what was it, patch -p to see the actual things that changed? There we go. So we have this, fix unsave enumcast, and it changed a bunch of stuff here. Proc decode, and there's some value somewhere in there, right? Who knows where, but it's somewhere there. So I could probably pipe it to grep, and this will be value. So I just see the lines with that. Oh, oops, not back tick. What's going on? Okay, I got a bunch of stuff. All right, so that's how we can extract, like, you know, history. Okay, everywhere $sign value changed. We have tons and tons of stuff because I guess that $sign value is used throughout all the queries to the database or whatnot. Return datetime value, get this. And duration seconds. Fun. I'm actually looking forward to re-implementing Seaboard protocol, but in Zig. I'm kind of excited for that. I want to get to the point where I can comfortably do that, and then do like a proper zig driver for SerialDB, because I know Dart driver for SerialDB and all the other ones, they don't implement the proper CPOR protocol. They just do everything like, let's do the easiest way. Let's connect through HTTP. Let's ignore WebSockets. Let's do everything via JSON. Ew, I don't like it. SerialDB is much better if you actually connect it properly. So now this code just gets me excited. All right, so we have tons of options to learn on how to actually search through that. So this probably takes a lot of practice, just like with NeoVim, right? Here's million commands. Figure out over time which ones you like using, okay? So the last really useful option is to pass to git log is a filter. Oh, the last really useful option to pass to git log as a filter is a path. If you specify a directory or a file name, you can limit the log output commits that introduced a change to those files. This is always the last option and is generally preceded by double dashes to separate the paths from the options. Oh, so let me just go to NeoVim again, because let's say we have our source, we have our serial private, and we have the separate CBOR directory. Not a lot of files here, but they're very important, okay? So what if we do that? So it's source serial private CBOR. So we're gonna do, we don't want to pickaxe, nothing like that. We'll just log stat and we do dash dash and path to file. So it will be source serial private CBOR. All right. And this is going to be directory. So will that work? Yeah, look at that. We've got some stuff. Okay, commit from 2025, 26. So this will be a bunch of stuff that I was doing just in that specific directory. All right, and that's it. That's the end. They were initially created and then some changes here and there. Beautiful. Okay, I am liking that. It's just a lot to remember and learn. So in the options to limit the output of git log, we'll list these and a few other common options to your reference. So just to have an idea, so dash something show only the last and commits, right? You just want to see last 20 commits, give me an idea what's going on. Since or after. Okay, so we have since and after. I mean, it's the same thing, right? So limit the commits to those made after the specified date, until or before. So I like that we have those alternatives. You can make it, I don't know, whatever fits the bill better. Author only show commits in which the author entry matches, committer, grep, and S for the pickaxe. For example, if you want to see which commits modifying test files in a Git source code history were committed by Junior Hamano on the month of October 2008 and are not merged commits, holy moly, you can run something like this. So yeah, you can ask very specific questions. Git log, we want pretty output with short hash, and then whatever the commit message from the author. Bam. Since beginning of 2008 October, but before the November. So basically, we set the range from 2. No merges, so that's another thing. And then the path is t/. I guess tests are stored in T directory. And there we go. Here are the things. Cool. Of the nearly 40,000 commits in the Git source code history, this command shows the 6 that match the criteria. Oh, so this is actually from public repository from the Git source code itself. So the Git source code has 40,000 commits. Ouch. That is a lot. Preventing the display of merge commits. Depending on the workflow used in your repository, it's possible that A sizable percentage of the commits in your log history are just merge commits, which typically aren't very informative. Yeah, it's just merging stuff. To prevent the display of merge commits cluttering up your log history, simply add the log option, no merges. Okay, great. Okay, we got through the chapter. So far, I'm very happy in how things are going. Alrighty. So, now is the fun part, undoing things. That's the thing that usually seems impossible in Git, to undo stuff. Okay, so at any stage, you may want to undo something. Here we'll review a few basic tools for undoing changes that you've made. Be careful, because you can't always undo some of these undos. Yeah, that's the scary part. You can undo, but you can't just... You might lose some info. This is one of the few areas in Git where you may lose some work if you do it wrong. So one of the common undos takes place when you commit too early and possibly forget to add some files, or you mess up your commit message. If you want to redo that commit, make the additional changes you forgot, stage them, and commit again using the amend option. So if git commit amend, this command takes your staging area and uses it for the commit. If you've made no changes since your last commit, for instance, you run this command immediately after your previous commit, then your snapshot will look exactly the same, and all you change is your commit message. Okay, so the same commit message editor fires up, but it already contains the message of our previous commit. You can edit the message the same as always, but it overrides your previous commit. Okay, so as an example, if you commit and then realize you forgot to stage the changes in the file you wanted to add to this commit, you can do something like this. Git commit and initial commit, right? So we create the initial commit, and then like, oh no, forgot something. Let's add this to our staging and commit amend. So that will basically target our last commit. So let's try that, okay? We're gonna go to our test one in our git log one line. We have that, okay, last change that we made was cleanup, okay? Can I do git log stat-1 to see the last commit, right? There we go, cleanup, and we just renamed this file here and there, okay? So let's pretend like, oh no, I need to do something more. Here, I think we have this. So this is the file that we moved, so no big deal. Let's say that in README, we were supposed to clean up some stuff too, right? So let's say something like a web browser here is pointless, right? We'll delete that line, and this was our cleanup, okay? Let's just add empty line at the end, write those changes, and in our Git, we should be able to see Git status as, so we can see that the readme.md needs to be, pushed, updated. For some reason, I still have existing not needed, so let's remove not needed. Whatever, we don't want that file. So I should be able to do git add readme, okay. Our status shows that we have our readme changes in staging. So I do git commit, just commit amend, enter. All right, so this fired up our thing. So we had our cleanup, and then we had just our extra stuff. So cleanup, I'm fine with that. All right, I just do quit and write, quit. Okay, did it do the thing? Git status looks like it did something. So our git log stat, there we go. Our stats are showing up for that commit now. But hey, you actually did something. So that's great, but how does it work when we want to push those changes? What if I did something of that sort? I made commit, pushed it to GitHub repo, right? To a remote. Push it there, and then I'm like, oh, I'm gonna amend this on my local machine. Can I send it again? That's something I don't know. I guess that will be our working with other things option. Although I'm tempted to try it, but maybe not. Alrighty, so great. Amend is awesome. So we did that. You end up with a single commit. The second commit replaces the results of the first. Okay. Note, it's important to understand that when you're amending your last commit, you're not so much fixing as replacing it entirely with a new improved commit that pushes the old commit out of the way and puts in a new commit in its place. Okay, so we're not editing anything, we're just making new one from scratch and just swapping it with the other one. Effectively, it's as if the previous commit never happened, and it won't show up in your repository history. Yeah, the obvious value to amending commits is to make minor improvements to your last commit without cluttering your repository history with commit messages of the form, oops, forgot to add a file, or darn, fixing a typo in last commit, right? Because how often it is like, oh, I made this small thing and now my GitHub workflow doesn't work. I hate when that happens. I always blame YAML. Okay, another note. Only amend commits that are still local and have not been pushed somewhere. There we go, there's our answer. Amending previously pushed commits and force pushing the branch will cause problems for collaborators. For more on what happens when you do this and how to recover if you're on the receiving end, read the perils of rebasing. That's a different book. No, that's just chapter 3.6. So we're gonna get there. All right, we're gonna get there. In no time, probably many hours, but sure. Okay, all right, good. And now we get our other thing that I was wondering this whole time: unstaging a staged file. The next two sections demonstrate how to work with your staging area and working directory changes. The nice part is that the command you use to determine the state of those two areas also remind you how to undo changes to them. For example, let's say you've changed two files and want to commit them as two separate changes, but you accidentally type git add everything and stage them both. How can you stage one of the two? The git status command reminds you. So git status on branch master, changes to be committed. And we have use git reset head file to unstage, right? And Josh says, just started learning Git a few days ago and your stream got recommended. Cool stuff. Live streaming the act of RTFM is hilarious. Yet it works. Act of RTFM. What do you mean by RTFM? Don't know that acronym. But yeah, I kind of like streaming as I'm learning and trying to explain it because it kind of forces me to go deeper. Because normally I would just skim and it's like, sure, I got it. And now I need to just keep blabbing about it and actually learn it. So yeah, I found a tactic to force myself to actually learn something. So we have this one was renamed, this one was modified, right? So these are the two changes that we did. So it's very similar to our other stuff that we were doing. So use git reset head file to unstage. Right below changes to be committed text, it says git reset head and a file to unstage. So let's use that advice to unstage the contributing MD file. So our chat here said that alternative use git reset, the older approach. So it was git reset this and then git checkout file name. So that's, oh, we can check out a file name. What the heck? So I'm not sure why this is called older approach. Git reset head contributing.md. On stage changes after reset. Bam. Git status. There you go. Renamed and not stage for commit is modified contributing MD. So we still have that. So not stage for commit. Use git add to update what will be committed, or use git checkout file to discard changes in working directory. Oh, okay. So this is like pre-git restore. So we have reset and check out. Huh. I wonder if we can target a specific file to reset it to some other commit. Like, hey, just pull this file from this random commit. That would be fun. The command is a bit strange, but it works. The contributing MD file is modified, but once again unstaged. So I want to see that in action. So let's say that in here, we're gonna say now our tech stack and maybe installation, right? Installation, we're gonna just specify that, what the hell? Why can't I do triple thing here? Oh, now it worked? This is weird. Okay, sometimes I don't get what NeoVim is trying to do. So let's say that will be what, npm install, right? And then we're gonna have, wow, now I'm pressing enter and it doesn't let me do anything. What the hell? Input. Here, please close it. No, edge. What the heck? Okay. I've never seen behavior like that in NeoVim. I have no clue what's going on. Oh, I think I know what's going on. It just tries to be smart and render it for me. But because of that, it just like, nope, you're gonna be confused. I think that's what's going on. So we have git bash, npm install, and I mean, I can just do whatever. Nope. npm run dev. There we go. And we just do, we already have this for some reason. I have no clue what the heck's going on. Right. Oh. What's our git status? Okay, we've got our readme, right? So that's good. Git diff. Whoa, look at all. This is a pretty bad file, but whatever. We're gonna go with that. Why not? So basically we've got our installation added here. So now the idea was that we could unstage it. So first we need to stage it, git add readme, right? And now it's in staging. So if I'm just gonna do git status without the S, look at that. It's the newer version that git restore staged and file to unstage. Huh. So they're already recommending the new approach. Interesting. But I can do the old way. Git reset head, and we're gonna do what? Readme MD? Bam. And here's our status. Is modified but not staged. So I definitely prefer the one of S. Yep. All right. That works. So I could, in theory, here do, like, to completely restore it will be git checkout. But here they're saying, hey, you can just do git restore. So you can do restore stage and then not stage. So we have kind of the same command for both, which is nicer. Restore, and this will be our readme because the edit was absolutely horrible. Okay, all right. So we see the all new version. So the command is a bit strange, but it works. The contributing MD file is modified, but once again unstaged. Alrighty. It's true that git reset can be a dangerous command, especially if you provide the hard flag. However, in the scenario described above, the file in your working directory is not touched, so it's relatively safe. For now, this magic invocation is all you need to know about the git reset command. Okay, we'll go into much more detail to what reset does and how to master it to do really interesting things and reset demystified. So something tells me I will be able to target files from maybe other branches or somewhere in the past, because I can imagine that this would be, I don't know, just to pull in changes from somewhere that, hey, please reset my current file into the state from somewhere else. And this way you could kind of pull changes from here and there, which would be kind of a fun way. Let's say you made one branch, you work on your project there, but it just became such a mess that you just want to, from the newest, just go create a new branch and maybe pull in some changes from here and there. I can imagine it being useful for something like that. And Josh says, RTFM stands for read the effing manual. Okay, yeah, that's the approach. Often when someone asks how an application/tool works in tech, a common response is asking if they've RTFM yet. A blunt way of saying read documentation. Okay, I guess I'm the kind of person that just doesn't ask questions online. I just sit at home and cry that I can't do anything. Or ask the AI now. But yeah, I get it. And yeah, reading the manual is awesome. Recently, I watched an interview, I think it was from half a year ago, maybe a year ago, of, I forgot his first name, but last name is Hashimoto. The guy that, started the whole HashiCorp. And one approach to learning any kind of new tech, even languages, is to literally sit down and read the entire documentation for it, like the formal specifications. So let's say if I went to learn Zig, right, Zig Lang, it doesn't mean that you go and read the, whatever is it, Zig guide or something. No, that means you go to documentation and you actually read this, the Zig language reference, which is lots of stuff. And then after that, he would go and actually kind of read through entire standard library to get a good grasp of what's there, roughly how it works. So in some way, when you think about it, it's like, oh my gosh, this will take me days to just read through it. But at the same time, when you actually read through that, you kind of get a really good overview of what is happening, often why, and all the things related. And you're like, I know, it's like gaining a superpower. So I need to start getting that approach. I kind of started doing that with NIM language, but I got to the point where I felt like I don't have enough knowledge about low-level programming on its own. There were too many references to C programming, which were like, I have no clue what's going on here. And now I'm basically learning Zig to get that knowledge so that maybe I can improve my NIM as well. So yeah, I will definitely want to read the manual again and kind of get more info about that. And yeah, this is supposed to be the book about Git. I just don't think I will be reading the actual documentation for Git, because that will be probably a million pages or just too cryptic to start with. All right, so where were we? Okay, so this is all about reset that we'll learn for now. All right, so another undo approach. Unmodifying a modified file. Okay, so what if you realize that you don't want to keep your changes to the contributing.md file? How can you easily unmodify it? Revert it back to what it looked like when you last committed or initially cloned, or however you got into it, however you got it into your working directory. Luckily, git status tells you how to do that too. In the last example, output unstaged area looked like this. So we had the thing of git checkout file, right? To discard changes. For us, it shows git restore file because that's the new approach. So it tells you pretty explicitly how to discard the changes you made. So git checkout, and we have dash dash, okay? Double dash. So that's how we specify the path and contributing MD. So something tells me this is because use git checkout to switch between branches, right? Hey, check out this branch. Well, what it means is that it takes that branch and pulls all of its whatever difference between yours and that branch and just applies it to your working directory. So you kind of fully switch. Something tells me you are able to check out your current branch you're on, the current head or whatever it is, and just a specific file or maybe a specific directory. You want to just, hey, reset everything in this directory. So that's kind of fun. I like that. It will be even more fun if you could just, again, pull in changes from a different branch in this fashion, which would be, I don't know. I just don't know how that would work. You can see that changes have been reverted. Important. It's important to understand that git checkout -- file is a dangerous command. Again, any local changes you made to that file are gone. Git just replaced that file with the last staged or committed version. Don't ever use this command unless you absolutely know that you don't want those unsaved local changes. If you would like to keep the changes you've made to that file but still need to get it out of the way for now, we'll go over stashing and branching and git branching. Okay, so stashing, it'll be fun to be able to do that from command line as well because it's such a nice concept. Okay, these are generally better ways to go. Alrighty, remember anything that is committed in Git can almost always be recovered. Even commits that were on branches that were deleted or commits that were overridden with amend commit can be recovered. See data recovery for data recovery. However, anything you lose that was never committed is likely never to be seen again. So whatever's in your staging or working directory, it's basically not safe because Git can at any moment, whatever command you're gonna give it, say, you know what, I'm replacing that file, bam, gone, even though you had some unstaged changes. I guess most of the time would warn you that, hey, you have some changes here. I'm not doing what you're asking me because you're gonna lose changes. But with something like reset or sounds like checkout, it could just reset it for you without asking you because I guess it's intended to be used for that purpose. Therefore, you know, it won't be asking you. Okay, so now we go to the more modern stuff. I'm doing things with git restore. Git version 2.23.0 introduced a new command, git restore. It's basically an alternative to git reset, which we just covered. From Git version 2.23.0 onward, Git will use git restore instead of git reset for many undo operations. So let's retrace our steps and undo things with git restore instead of git reset. So unstaging a staged file with git restore, right? So we already learned how to do that. So the next two sections demonstrate how to work with your staging area and working directory changes with git restore. The nice part is that the command you use to determine the state of those two areas also reminds you how to undo changes. So yeah, if you have a new version, you get this thing, right? So, you know, we have the same situation. We do restore stage, so we already use that. Bam, done. And then you get the git restore file. So I'm modifying modify file with git restore. Again, hey, here's your hand. And do that. Okay, so that's it. It's just copy paste whatever was on top, just with a more modern command. It's important to understand that git restore file is a dangerous command. Of course, and local changes made to the file are gone. Yeah, Git just replace them. Don't ever use this command unless you absolutely know that you don't want to keep that you don't want those unsaved local changes. All right, next, we know how to undo basic stuff. Amend will be useful, and all those restores will be very, very, very useful. Okay, so, wow, this chapter isn't that long. Working with remotes. Finally, we're starting to do something with that's not just on our local machine. We'll work with something, some GitHub repo or something. So let's see. Git basics, working with remotes. To be able to collaborate on any Git project, you need to know how to manage your remote repositories. Remote repositories are versions of your project that are hosted on the internet or network somewhere. You can have several of them, each of which generally is either read-only or read-write for you. Okay? Collaborating with others involves managing these remote repositories and pushing and pulling data to and from when you need to share work. Managing remote repositories includes knowing how to add remote repositories, remove remotes that are no longer valid, manage various remote branches and define them as being tracked or not, and more. In this section, we'll cover some of these remote management skills. When I read about that, I'm just starting to wondering if it's possible that, let's say I'm doing something on my computer, right? I have GitHub repository checked out on my computer locally, right? I wonder if, because sometimes it makes sense to push those changes to GitHub or whatever, but maybe I'm like in the middle of something that I really want to be just one cohesive commit or whatever. Or I just needed to suddenly leave or something. And I have it only in local changes I wasn't able to push. Is it possible for, let's say, I grab my laptop and specify the version on my PC to be my remote and kind of work that way? That would be interesting, right? That you have your local version of that. Something tells me it's possible. It's just I have no idea how to do it yet. Remote repositories can be on your local machine. Oh, there's partial answer number 1. Wow. I keep doing that. I have a question, and the next line is just an answer, so I totally didn't have to go on a rant. It is entirely possible that you can be working with a remote repository that is, in fact, on the same host you are. The word remote does not necessarily imply that the repository is somewhere else on the network or internet, only that it is elsewhere. Working with such a remote repository would still involve all standard pushing, pulling, and fetching operations as with another remote. So I actually heard about this concept mostly through, I have an idea to make some search as a service thing that will be an open source project. So you're going to have that core version of it as an open source project on GitHub. But I also want to make this kind of extended version that has all the user management and will be deployed by me on some infrastructure and whatnot that builds upon that open source project. Therefore, it adds to it. It still needs all of its source code. It just extends it, replaces some parts. So the idea that, AI gave me is like, hey, you can have this open source repository marked as a remote to your own. Therefore, you can make it like always pull changes from the open source repository into your larger repository that's, not open source. So this sounds like something that could work that way. Alrighty, showing your remotes. To see which remote servers you have configured, you can run the git remote command. It lists the short names of each remote handle you've specified. If you clone your repository, you should at least see origin. That is the default name Git gives to the server you cloned from. So from something like test 1, we should have nothing here, right? Git remote, because that was just git init here, and yeah, there's just nothing. What if we're gonna go to something like surreal and git remote? There we go. We've got origin, and that's all we have. So git clone, right? This thing, cloning, and blah, blah. And therefore git remote will be origin. You can also specify -v, which shows you the URL that Git has stored for the short name to be used when reading and writing to that remote. So with the add -v, and there we go. So, oh, this is, oh, I did not expect that. So look at that. So now it shows up twice. One is the URL used for fetching, and one is for pushing. Ooh, that's fun. If you have more than one remote, the command lists them all. For example, a repository with multiple remotes for working with several collaborators might look something like this. Git remote v, excuse me. We can push and pull to all those people for some reason. What the hell? What? So that's the thing that I'm unfamiliar with, because I'm so used that everyone uses GitHub that there's this one origin somewhere there, just one centralized thing. You're still kind of dealing with the centralized idea. Still, you have fully working local copy, but every time you're pushing somewhere is just that centralized thing that everyone reads from, right? And pushes to. So, this is a new concept. Like, hey, I have other contributors and I'm just gonna push to their repos. What the hell? I mean, I guess if it represents the same thing, but how the hell do you... this is very confusing. This means we can pull contributions from any of these users pretty easily. We may additionally have permission to push to one or more of these, though we can't tell that here, right? This is just saying that fetch and push for pretty much everything. But yeah, no permissions here. Notice that these remotes use a variety of protocols. We'll cover more about this in getting Git on server, right? Because these are HTTP, these are Git, and these have Git add github.com. So this looks like some kind of SSH. This looks like some other Git protocol, and this one looks like it uses HTTPS. Alrighty. So let's learn about adding remote repositories. We've mentioned and given some demonstrations of how the git clone command implicitly adds the origin remote for you. Here's how to add a new remote explicitly. To add a new remote git repository as a short name you can reference easily, run git remote add, short name and URL. So we have that origin, right? Git remote add. Shorthand will be PB and HTTPS, GitHub, Polboon, tickgit, right? And then it's going to be showing up here as this PB. All right. Now I can use the string PB on the command line instead of the whole URL. Oof. Wow, that's nice. For example, if you want to fetch all the information that Paul has, but that you don't yet have in your repository, you can run git fetch pb. So we'll say git fetch this and say remote. Counting objects, 43, done. Compressing and total delta, whatever, unpacking, and we can see that there's a new branch going from master to pb master. Excuse me, so I guess we just kind of pulled in without pulling in, just fetched info. Oh yeah, so I guess fetch is, hey, fetch it to my Git database, but not fetch it, but not pull it into my working directory. I guess that's the difference, right? So it shows up as pb/something. Interesting. So it basically shows up as some kind of branch. So whatever pb has as master would be pb master and whatnot. All right. Paul's master branch is now accessible locally as pb master. You can merge into one of your branches. You can merge it into one of your branches, or you can check out a local branch at that point if you want to inspect it. We'll go over what branches are and how to use them in much more detail in Git branching. All right. So fetching and pulling from your remotes. As you just saw, to get data from your remote projects, you can run git fetch and a remote. All right. The command goes out to that remote project and pulls down all the data from that remote project that you don't have yet. After you do this, you should have references to all the branches from that remote, which you can merge in or inspect at any time. Okay? If you clone a repository, the command automatically adds the remote repository under the name origin. So git fetch origin fetches any new work that has been pushed to that server since you cloned, or at least fetched from it. It's important to know that the git fetch command only downloads the data to your local repository. It doesn't automatically merge it with any of your work or modify what you're currently working on. Okay, so it only adds it to the Git database, but not your working directory. You have to merge it manually into your work when you're ready. If your current branch is set up to track a remote branch, see the next section and Git branching for more information. You can use the git pull command to automatically fetch and then merge that remote branch into your current branch. This may be an easier or more comfortable workflow for you, and by default, the git clone command automatically sets up your local master branch to track the remote master branch, or whatever the default branch is called, on the server you clone from. Okay, so running git pull generally fetches data from the server you originally cloned from and automatically tries to merge it into the code you're currently working on. So we have this term added here of tracking a branch. So the way I understand it so far is that that remote, let's say origin or maybe some other remote, which is the, let's call it an instance of the repository on some other computer. So notice that when this was executed here, git remote add, oh no, this one. Oh yeah, he added a remote, right? He added a remote, so looked like he already had origin, right? Wherever, let's say GitHub. But he also added somebody else's fork of that repository as another remote, okay? And it shows up as PB. That's his shorthand for it. So when he ran git fetch PB, what it did is into his local repository, it went on and loaded all the data about that repository, but from that remote. And then it figured out, you know what? I'm going to create those branches locally or make them available, all the branches that are on that other repository. And at that point, it's the master from the PB remote was mapped to, hey, this will be PB/master, right? That's how you can get to it. The same thing, prefix with the remote name and tcgit, okay? So at that point, if you're gonna create, something, so I guess they're not tracked yet unless you check out that PB master. It's gonna create the actual local copy of that branch. You can probably give it whatever name you want, but it will mark it as tracked, as in it's kind of connected to it, so that something like push and pull will actually automatically apply it to that remote, rather than you having to specify, hey, fetch this from that repository, or I don't know how you would even push. But there's this concept of tracking where you can basically connect your local branch to some remote branch, and they can have whatever different names they want. All right, so from Git version 2.27 onward, git pull will give a warning if the pull rebase variable is not set, whatever that is. Git will keep warning you until you set the variable. If you want the default behavior of Git as in fast forward if possible, else create a merge commit. Git config global pull.rebase false. Okay, so I guess you can do some kind of rebase on pull, and I'm not familiar with rebasing. I don't seem to have ever had a need for that somehow. If you want to rebase when pulling, git config global pull rebase true. So we're not touching that for now. Yeah, although default is nice, so we could probably literally do that, right? We want the default behavior, so we're gonna throw that into global our per user config. All right. All right. So pushing to your remote. So we know that we can clone and we can kind of pull whatever. We didn't have any specific examples yet though. So pushing to your remotes. When you have your project at a point that you want to share, you have to push it upstream. The command for this is simple. Git push the name of the remote and the name of the branch. Okay, so we want to push, I don't know, my branch ABC. Oh, sorry, I want to push to origin, which will be GitHub, for example, my branch, which is, I don't know, feature ABC. If you want to push your master branch to your original server, again, cloning generally sets up both of those names for you automatically. Then you can run this to push any commits you've done back up to the server. So git push origin master. There you go. This command works only if you cloned from a server to which you have write access, and if nobody has pushed in the meantime. If you and someone else, if you and someone else clone at the same time and they push upstream and then you push upstream, your push will rightly be rejected. You'll have to fetch their work first and incorporate it into yours before you'll be allowed to push. See Git branching for more detailed information on how to push to remote server. It's just so much content that refers, hey, see Git branching, see Git branching. Seriously? How about you restructure content so that we don't have to have so many references for a future article? Come on. And hello, Taras. How's it going for you? How's Git going? Pretty good. I'm starting to get familiar with all the local stuff and now starting to learn about remotes, and the entire world is opening up. It's like, okay, this is a lot going on. your regular whatever. Something like GitKraken really abstracts away a lot from you, so you don't have to think too much. Here it's just like, okay, there is a lot going on behind the scenes. And there's a lot of questions because it seems like you have a lot of things that you could do potentially. Yeah, it's fun. Okay, so, well, push which remote and which branch. Okay, that makes sense. So inspecting a remote. So notice how we're kind of being showered with those commands without, they're all related to branches and whatnot, but we know nothing about branching. Come on. Inspecting a remote. If you want to see more information about the particular remote, you can use git remote show remote command. If you run this command with a particular short name, such as origin, you get something like this. So we should see the fetch URL, push URL, head branch, remote branches, and okay, these, for example, are tracked. Local branch configured for git pull. Master merges with remote master. Okay. I guess this is our local master branch and it's connected to master, right? That's how it's being tracked. A local ref configured for git push. Again, master pushes to master, up to date. All right, so let's run in our serial.nym git remote show origin. What do we have here? So we have our serial stuff here. Head branch main, remote branches. So we have both of them tracked. Local branch configured for git pull is main, okay? And for push is main as well, and everything's up to date. I don't have anything out of date. All right, and how are you, Taras? How is it going? What's happening on your end? Okay, so we went through that, and now what? It lists the URL of the remote repository as well as the tracking branch information. The command helpfully tells you that if you're on a master branch and you run git pull, it will automatically merge the remote's master branch into the local one after it has been fetched. It also lists all the remote references it has pulled down. That is a simple example you're likely to encounter. When you're using Git more heavily, however, you may see much more information from Git remote show. So here we have, let's say, URL and fetch and push, right? Head branch master, and we have some remote branches like those three, and issue 43 and 45 are new. Next fetch will store in remote origin. Okay. So I guess they just showed up. And then we have some stale one that has been attached for a long time. Local branches configured for git pull. So these are the checked out branches, right? The dev branch, and it shows that it merges with this and master, and then refs configured for git push. And suddenly we have 3 for push, while only 2 for pull. Very interesting. So we have markdown strip pushes to markdown strip. Interesting. So you can have some async, whatever, not async, asymmetric stuff, I guess. That, okay, you can't pull those. You can't pull markdown strip, but you can push it for some reason. Why not? This command shows which branch is automatically pushed to when you run git push while on certain branches. It also shows you which remote branches on a server you don't yet have, which remote branches you have that have been removed from the server. Removed. None of them are removed in this case. Okay. You have that have been removed from the server, and multiple local branches that are able to merge automatically with the remote tracking branch when you run git pull. All right. Okay. And that says work low energy. I can understand that. I had basically an entire day of prepping for interviews. So this is a nice little break from all that. Even though I'm still trying to fit more, this is a break, definitely. Alrighty, so we know that we can inspect with, git, what is it, remote v? Git remote v? Not remove. Jeez. Remote v. Okay, so this shows us our remotes, while we can target specific one with, hey, show origin, right? Good. So lastly, we have renaming and removing remotes. Wow, that's lots of R's. And Tara says, I believe stale refers to removed. Oh, okay. Stale, use git remove prune to remove. Interesting. Well, that's not very clear. Huh. Go figure. Thank you for pointing that out. So you can run git remote rename to change your remote's short name. For instance, if you want to rename PB to Paul, you can do so with git remote rename. Okay, git remote rename PB Paul. And then remotes, we have that. So in theory, I could do git remote rename origin to, I don't know, GitHub. How about that? Done. So if I'm gonna do remotes, I have the GitHub one. There we go. So I can also do show GitHub, and we will see everything updated. This is tracked. This is tracked. Main merges with remote main. Okay, and all that stuff. So it doesn't, okay, because we're already showing stuff for GitHub. Okay, all right. So it seems like you can have local branches, like I could have probably, like maybe this branch tracking one specific remote, another branch tracking another remote, right? All those weird things. Okay. If you want to remove a remote for some reason, let's say you've moved a server or are no longer using a particular mirror, or perhaps a contributor isn't contributing anymore, you can either use git remote remove or git remote rm. All right, so git remote remove poll, and it will just remove it. Right. Once you delete the reference to a remote this way, all remote tracking branches and configuration setting associated with a remote are also deleted. Okay, so all remote tracking branches. So I guess my local branches stay. It's just all the history related stored just for that remote are disappearing. Okay, and like the pre-made branches that you could start tracking or something. Okay, all right. We're getting slow into the weeds, and what the hell? So we learn about tagging before we get our branches. What's next? Aliases, summary, and then we go to branches. What the hell? I must say I don't enjoy the order of that book. It's just like, in my opinion, one should learn about branching before even dealing with remotes, or especially with tagging, or just additional things like aliases. Come on. Seriously. Very, very, very confusing. I mean, maybe there is something behind the scenes, but from my perspective right now, this is like pushing too much of something that I can't practically use yet, because, okay, I'm reading about branches everywhere, tagging them and whatnot, but I can't even make one. Come on. Toss says branches, sorcery according to ProGit. Really, I mean, branches are nothing crazy, at least in basic concept to get the job done. Unless, I don't know, maybe at the time of when Git was introduced, it was such, such a, like you said, sorcery that it was so confusing, but nowadays, not really. All right, so tagging. Well, let's get through that. I actually might finish at tagging because, oh no, after tagging we have aliases and that's it. So I think we're gonna finish that. And another time we'll actually finally focus on branching. Maybe we'll be able to get back to those, some of this stuff to kind of have a refresher after we get through branches. Alrighty. Most VCSs, Git has the ability to tag specific points in a repository's history as being important. Typically, people use this functionality to mark release points, for example, v1.0, v2.0, and so on. In this section, you'll learn how to list existing tags, how to create and delete tags, and what the different types of tags are. Okay, so we've got different types. So listing your tags. Listing the existing tags in Git is straightforward. Just type git tag with optional L or list. Git tag. And we have no tags in this repo. I guess I could go to something like, nope, more. Do I have something here? Let's say I would go to something like, let's go to stacks. How about that? Okay, and we're gonna do git tag. There we go. We have tons of tags. We went from full-on build versions to patch, and yep, there we go. Oh, it orders them. Oh, it doesn't order them properly. It orders them with like by character. So 0, 1. Okay, sure. And that's, wow, tons more. Okay. Great. So that's great. With optional L, what will L do? Nothing. It's the same thing. This command lists the tags in alphabetical order. The order in which they are displayed has no real importance. You can also search for tags that match a particular pattern. The Git source repo, for instance, contains more than 500 tags. If you're interested only in looking at the 185 series, you can run this git tag list, and we have v185 and whatever is after that. So it could be 855 as well. But 185, and we also get things like the RC zeros and a bunch of other stuff. All right, makes sense. So we could do git tag, and we want, for example, 0.8 and star for anything after that. And we have 2 versions. All right, there we go. Listing tag wildcards requires L or list option. Oh, so the list is when we specify those. Okay. If you want just the entire list of tags, running the command git tag implicitly assumes you want listing and provides 1. The use of L or -- list in this case is optional. If, however, you're supplying a wildcard pattern to match tag names, the use of L is mandatory. Alrighty. So that's simple. Or you could just do git tag and just pipe it to, I don't know, grep, and you're looking for 1.8. Oh, sorry, 0.8, right? And there we go. It's just included 10.8. All right. Good. Creating tags. Git supports 2 types of tags, lightweight and annotated. All right. A lightweight tag is very much like a branch that doesn't change. Why do we have another mention of a branch? It's just a pointer to a specific commit. It's like as if they had branch tutorial before all this, and they decided to just, you know what, we're gonna push it later. We'll just confuse the hell out of everyone. Okay, so a lightweight tag is very much like a branch that doesn't change. It's just a pointer to a specific commit. Annotated tags, however, are stored as full objects in a Git database. They're checksummed, contain the tagger name, email, and date, have a tagging message, and can be signed and verified with GNU Privacy Guard, GPG. It's generally recommended that you create annotated tags so you can have all this information. But if you want a temporary tag or for some reason you don't want to keep the other information, lightweight tags are available too. So annotated tags. Creating an annotated tag in Git is simple. The easiest way is to specify -a when you run the tag command. Git tag something something. So A is annotated, what's the name of the tag, and message that it's gonna hold. Okay, so let's go back to our temp git temp 1, right? Oh, come on. Temp git test 1. There we go. So we could tag git tag annotated version 0.1. There we go, or 0.0.1. Beautiful. Dash beta beta 1 0 better. And with message just starting out. There we go. Bam. So no confirmation when you run git tag. We have our first version. There we go. Can we create another one on the same branch or on the same thing? So beta 0 dash pre-release. Okay, we're gonna do that. Enter. Okay, so we have 2 tags. Beautiful. The M specifies a tagging message, which is stored with the tag. If you don't specify a message for an annotated tag, Git launches your editor so you can type it in. All right. You can see the tag data along with a commit that was tagged by using the git show command. So git show 1.4, and it shows that. So I wonder if git show allows you to point at different things. Git show, whoa, v0, why did I do that? Beta 0, there we go. There we go, git show. Bam, tagger and date, just starting out or not. And then we go with the commit. Oh, the commit it's attached to, right? And what happened here was cleanup, and what changed? Similarity index 100%. Oh, between the diff, that's too interesting. All right. That shows the tagger information, the date the commit was tagged, and the annotation message before showing the commit information. All right. So lightweight tags. Another way to tag commits is with a lightweight tag. This is basically the commit checksum stored in a file. No other information is kept. To create a lightweight tag, don't supply any of the A, S, or M options. S. Whatever S is. Just provide name of the tag, git tag, and something, right? So we're gonna do git tag total 0, and that's it. So git tag, and we have, yeah. So what I'm gonna do, show total 0. Okay, so total 0. We have no information about the tag. We go straight to the commit. All right. Makes sense. It's just a pointer at the commit, so we can kind of name a commit to refer to it, maybe. Wonder if that's value use case. All right, this time if you run git show on the tag, you don't see the extra tag information. The command shows the commit. All right. So tagging later. You can also tag commits after you've moved past them. Suppose your commit history looks like this. Bam. Now suppose you forgot to add the project add 1.2, which was the update rake file. Wow, long time ago. You can add it after the fact. No tag to tag that commit to specify the commit checksum or part of it at the end of the command. Okay, so we can create a new tag and target it. So if we're gonna do git log 1 line, we have all those 3, and the 1 line shows them shortened, so we should be good enough. So we can do git tag v minus 1. Sure, v1. Let's make it annotated, right? A v negative 0.1. And we specify, let's say, this one. So it'll be 62528C8. Okay. Bam, that should launch our editor, and we can do something like this message doesn't matter. Okay. Quit and write. No, I guess we just quit. No. Wait more. What? How do I save it? This message doesn't matter. Okay, because I'm gonna do write all. I mean, that worked. Oh, not QW, WQ. Oh, I'm an idiot. There we go. Could do the tag, so git tag, and we have all more of them, right? We have the version negative 0.1. You can see that you tagged the commit, okay? And the show will show us that, hey, this is regarding a specific version, right? So we do show, and this will be the v01. And besides the saying like, hey, this message doesn't matter, we have the commit that is define project and git ignore, and we have all the other information. So we properly tagged the thing. Beautiful. And Tara says show works with commits, branches, and whatnot. So awesome. So I could probably do git show, what would be 625 2. And I guess that should be enough to identify it, right? There we go. Or the start git show and just shows it's the commit. Okay, that's awesome. Shows us all the information, I guess. All right. Sharing tags. By default, the git push command doesn't transfer tags to remote servers. You will have to explicitly push tags to a shared server after you have created them. This process is just like sharing mod branches. You can run git push origin and a tag name. Okay, git push origin version 1.5, right? Counting objects, 14, whatever, pushes it. And hey, there's a new tag. Our local tag translates to this one on the remote. I guess they could be different names in case maybe there's a conflict already or something. Who knows? If you have a lot of tags that you want to push up at once, you can also use the --tags option to the git push commands. This will transfer all of your tags to the remote server that are not already there. Okay, so if you have some clone of it, I mean something that already is present in your repo, it's not gonna do that. What if you have a conflict? Can you have a conflict on tags? Let's say you created tag 1.5 somewhere in the past, or like as you're working, and by the time you're pushing it, the remote already got that tag as well. How does that show up? I guess that's when you will want to rename them or something. I don't know how that will pop up, but it's an interesting idea. So git push origin tags, and yep, there you go. Both of them pushed. Now, when someone else clones or pulls from your repository, they will get all your tags as well. So you have option of deleting tags. To delete a tag on your local repository, you can use git tag -d for delete tag name. For example, we could remove our lightweight tag above as follows. Bam. Note that this does not remove the tag from any remote servers. There are two common variations of deleting tag from a remote server. So we're gonna get to that. I just want to remove the, I don't know, git tag. Let's remove the pre-release, right? So git tag -d to delete v0 pre-release. There we go. Delete it. So now git tag. There we go. No more. It's interesting that it doesn't show like, you know, some of the things, status of them or anything. Alrighty. So there are two different ways to remove stuff from there are two common variations for deleting tags from a remote server. The first variation is git push which remote to and reference tags tag name. Oh dear. So I guess it takes an effort, right? And it will show up as deleted. Yay. The way to interpret the above is to read it as the null value before the colon is being pushed to the remote tag name, effectively deleting it. Oh, so I guess we could, that's how one would, oh. So in theory, I could do git push, let's say my git push origin, and I guess I would have v0 something, or my tag, and I want it as tags, I don't know, v0.0.0.1, right? I guess this suggests that I want to push my tag as this name, possibly, but I am not sure. It's interesting because this is null, it's nothing here, so maybe. The second and more intuitive way to delete a remote tag is with git push origin dash dash delete and tag name. Okay, this is much nicer. Okay, we need to keep that in mind. Something tells me the idea is to reference this book from time to time to get back and like, how did I do it? Now we just have an overview of, okay, that's how you do things roughly, and yep, that's pretty much it. All right, checking out tags. If you want to view the versions of files a tag is pointing to, you can do git checkout of that tag. Although this puts your repository in a detached head state, which has some ill side effects. Okay, so git checkout version 2.0.0. Now switching to 2.0.0. So I guess this is like branches, right? It's just detached head state. I guess that means that we're somewhere in the middle of the whole thing. You're in detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by performing another checkout. Okay, so in theory, we could do git checkout v01. And bam, there we go. Switching to v01. You are in detached head state. You can look around, all that fun stuff. If you want to create a new branch to retain comments to create, you may do so now or later by using -c with switch command. For example, git switch -c new branch name. Interesting, or undo operations with git switch dash. So again, git switch, something we don't know about yet. Turn off this advised by setting config variable advised detached head. Okay, great. So looks like we got some extra info added that we're in a tag v01. So let's do git log, one line. Come on, one line. So look at that. It looks like our future history is gone. And that says Stacks uses git switch. Of course it does. And used to do a lot of stuff probably behind the scenes to get all this information. Alrighty. So we're in on that, and okay. How do we get back? In detached head state, if you make changes and then create a commit, the tag will stay the same, but your new commit won't belong to any branch and it will be unreachable except by the exact commit hash. Thus, if you need to make changes, say you're fixing a bug on an older version, for instance, you will generally want to create a branch. And wow, we have an info to create a branch, just out of context. Git checkout -b for, I guess, branch version 2, v20. Switch to a new branch version 2. If you do this and make a commit, your version 2 branch will be slightly different than your v2.0 tag, since it will move forward with your new changes. So do be careful. So let's do that. So let's make a quick change, maybe to our README. Okay, ignoring swap file, whatever. Oh, because I guess we have it open in another directory. We're just gonna add. Yay! So excited. I'm not, but I need to write something. So write quit. There we go. So git status. We have that readme. So they're suggesting, hey, git checkout dash B for branch, I guess, and do alternate reality. Okay. And what? A tag v2.00. Oh, I guess this is so we want to branch off, not like the head or whatever. We want to branch off our v01. Switch to new branch, alternate reality, right? Get log, one line graph. Doesn't show much. Great. So I guess we still do git status. So git add, readme, there we go. Git checkout. No, not git commit m splitting the timelines. Okay. Bam. So we created this thing on this branch, and now our git status is empty. Git log graph. Nothing crazy here either, right? So yeah. And now we have git aliases, and we're basically left with unusable state of this book. So I'm gonna use my existing knowledge and do git checkout main, I believe. Switch to branch main, git log one line graph. And what do we have here? We don't even see that stuff there at all. It's like all the stuff we did is lost. Okay. So I guess we're definitely missing some knowledge on how to do stuff there, because our branch just doesn't show up. All right, so let's finish with git aliases, because after that we go to next chapter, right? So this will be the last chapter to tonight. Git basics, git aliases. Before we move on to the next chapter, we want to introduce a feature that can make your Git experience simpler, easier, and more familiar. Aliases. For clarity's sake, we won't be using them anywhere else in this book. But if you go on to use Git with any regularity, aliases are something you should know about. Oh yeah, just to not type a million things. Git doesn't automatically infer your command if you type it partially. If you don't want to type the entire text of each of the Git commands, you can easily set up an alias for each command using git config. Here are a couple of examples you may want to set up, like git config this, git config that. So looks like we already have that. If I'm just going to do git config, right? Looks like we have alias co for checkout, branch, br for branch, ci for commit, and st for status, which is exactly the same. Okay, sure. That's surprising. So status will be just st. What if I want to have status s? This means that, for example, instead of typing git commit, you just need to type in git ci. As you go on using Git, you'll probably use other commands frequently as well. Don't hesitate to create new aliases. This technique can also be very helpful in creating commands that you think should exist. For example, to correct the usability problem you encountered with unstaging a file, you can add your own unstage alias. Git config global alias unstage, which will be reset head and dash dash. So we can do alias unstage something. So in my case, I would like to do git status dash s, right? That'd be fun. Yeah. I mean, oops, the hell. Quit all, come on. So in theory, if we go to our temp, git and test one, right? If we're gonna do some whatever package JSON, and we're gonna modify it to, let's say, have version 0.9. I can do git st for status. There we go. We have our own style. Beautiful. Git add read, wait, package JSON. Git st. There we go. Beautiful. And we have it staged, right? We want to unstage it, so we could, in theory, make an alias to like fully unstage or something that instead of using the head would like do other stuff, but doesn't matter now. I like the st for status. What was, by the way, git restore staged package JSON and git restore. I mean, the same command just without the staged. And there we go. Done. It didn't take that long. Okay, so great. This makes the following two commands equivalent. Bam, bam. Git unstage file A, git reset head. This seems a bit clear. Also, it's also common to add last command like this. Git config is global alias last. Log one head. Okay, all right. This way you can see the last commit easily. All right, I see. As you can tell, Git simply replaces the new command with whatever you alias it for. However, maybe you want to run an external command rather than a git subcommand. In that case, you start a command with an exclamation character. This is useful if you write your own tools that work with a Git repository. We can demonstrate it by aliasing git visual to run git k. Okay, git config, and we do alias visual, and it will just run git k. Okay, so I could possibly do like visual and do whatever was the name, lazy git, right? And I would basically have that. And I could do that. I'm hoping that the moment I understand more about Git, how it works behind the scenes, this specific interface will be more approachable, because right now it's kind of crazy in places. So yeah, that's that. All right, so here's a summary. At this point, you can do all the basic local Git operations: creating and cloning repository, making changes, staging and committing these changes, and viewing the history of all the changes the repository has been through. Next, we'll cover Git's killer feature, its branching model. Okay, so that will be next time. I don't know exactly when. We'll see. But yeah, that's pretty much it. So I hope somebody learned something from it. I know I did. So thank you for watching. Thank you for hanging out with me. And good night.